To start, we will utilize the support circuitry from this master design to start building our reuse blocks. From EDM, we can open the design. Once open, we will navigate to the support circuitry page by pushing through the block from the top block diagram. Circuitry like standard I/O interfaces, USB, PHY, etc. are good candidates for using design reuse blocks. Using circuits already created in this master design, we will create blocks for each of the 3 circuits on the support page. Start by selecting the block icon. Draw a box around all the circuitry of interest, making sure nets that will be providing input and output to the block are not included. To take advantage of managed block reuse, you need to use hierarchical blocks like the ones we've created here. Once completed, the block needs to be tagged as a managed block and its type set to logical physical, as the reuse block will contain schematic and layout content in this case. Packaging will then check these newly created blocks for errors. If okay, we can send information over to layout. After forward annotation has completed, the layout portion of the design can be completed. Let's now create the physical layout block from our USB circuit we've already placed and routed. From the Component Explorer, we can quickly locate and select the components used for this USB block. With the components selected, we can now define the managed block area, which contains all the layout information we want to save into the block. It's also a good idea to name the block with something descriptive. We will also mark the block as published, which is required to send to library. In addition, you can define the origin of the block and exclude content you do not want published. This now allows us to publish these blocks to the library and add comments, giving others useful information about the block. Now that the blocks have been published, using the EDM application, we can search the library using parametric capability to find blocks we would like to use or preview before adding. Automation creates a library cache, allowing others on the design team or in dispersed groups to use blocks in their designs. Using search inside of Designer, the engineer can now narrow down the selection list using parametric searching capabilities. If needed, before adding, you can remap layers, global nets, and buses to match those in your design. To add, simply drag your selection into the design. The block will be added and all constraints stored with the block will be merged. After completion of adding your blocks, a quick forward annotation will now allow you to place the blocks in layout. With placement already started in our design, we'll open the Component Explorer and 3D View to help us locate the components for our reuse blocks. Reuse blocks appear with a special reuse icon in the Component Explorer. These blocks can be selected, dragged, and dropped into either the 2D or 3D view. When dragging the SD circuit into the 2D view, notice a complete circuit is added: component placement, routing, shapes, and planes. Using keyboard shortcuts, you can rotate or flip the block as needed. Lastly, we'll place the USB block and rotate so the USB connector is facing the edge of the board. Managed blocks are added in a frozen state so they cannot be edited by accident. If needed, you can break a block for editing. This only affects the local copy of the block. As the design teams start using blocks in their designs, the author of a block will note it's been completed and request approval from the design team lead. This request for approval is initiated from the EDM Design Cockpit. The approver, also using the EDM Design Cockpit, can review the block using the Collaboration Viewer. In this example, the approver is looking at 3 test points in the upper right corner of the circuit. Notice when the test point is selected, it cross-probes to the part in the schematic and provides detailed information about this item. It's been determined these test points are not required. As such, notes are being added stating they need to be removed. From this viewer, you can look at both the logical and physical portions of the design, cross-probing between the schematic and layout views, changing visibility and turning layers on and off. This allows a person reviewing a block or design to have the same control as if they were in Designer or Expedition. The design lead has now requested a change to be made, so the prior request for approval has been rejected and the design is placed into ECO flow. In the ECO flow, the designer has been notified of the change needed to remove test points in the USB UART circuit. Launching the design from EDM, the designer can now go into the master block and make the requested changes. At this point, the layout engineer needs to update the master block layout. This is accomplished by removing test points and related traces. The block is then republished back to the library but is marked as certified pending in the ECO flow and is once again sent back to the design lead for review and approval. During the review process, the previous version will need to be compared to the new version. The integrity checks and comparisons performed by the authorized block managers shall include a visual comparison of the schematic as shown here. Note the graphical representation of the changes along with hyperlinks to the locations of the changes. The layout representations are also compared in order to observe and understand how the changes could potentially impact the consumers of the blocks. Once the compare and review are completed, changes to the updated master block can be approved. When a block undergoes change, all the consumers of the block are notified of that change. As the consumers of the change block open their designs, they are notified in the project integration window that a managed block has changes detected and an update is required. In this example, the engineer pushes into the updated block to verify the test points have in fact been removed. Once the schematic has been updated, a simple forward annotation to the layout will complete the update to the design. Let's switch over to another area of PCB design that is the most time-consuming part of the process: placement and routing. We will begin our design by using Component Explorer to perform initial floor planning to give us an idea as to where component groups will be placed in the design. These planning groups can be created in Expedition Layout by the PCB designer or up front by the electrical engineer and Expedition designer. Notice how the netline bundles are updated dynamically with each change to the placement. The net bundles show the estimated width of the area required for routing for a given group of nets. Let's take a closer look at the DDR4 circuit group. Notice this is a hierarchical group containing 6 sub-component groups. We will place all 6 of the sub-component groups along the left side of the board. Once the DDR4 groups are placed, we can move on to some initial route planning. Keep in mind that all this planning is being performed before a single component has been placed. Using Net Explorer, we can identify our DDR4 byte lanes and begin pre-planning using sketch plans. Even though no components have been placed, we can sketch in routing paths of traces early in the design phase, allowing others on the design team to see the intent of our routing. Once a bus lane has been selected, we draw a sketch path on the layer we'd like those nets to be routed on. These plans will remain consistent while we continue adjusting placement. Notice we can easily edit the sketch paths like we can individual traces. Now that we've completed our initial placement of routing paths for all the DDR4 nets, we can complete the placement of the individual components. As components are being placed, the sketch paths remain and adjust with the component locations. As we continue to place components, we are notified by the design team that this circuit has already been used in another design. To save time, we will take the placement from a finished design and copy it into this design. If this circuit continues to be used in other designs, a managed reuse block should be considered for the future so it can be more easily shared with the design teams. As we continue placing copied circuits, we will use the hover alignment feature to ensure each circuit is placed along the same y-axis. As we modify some of the placed parts, the sketch plans remain, adjusting to stay aligned with their associated components. Sketch planning allows the designer to add shielding rules to assist with high-speed design requirements. Simply right-click over a sketch plan and choose a shielding rule created previously using Net Explorer. Once we've made our final adjustments to the sketch plans, simply select all the sketch plans you want to route and choose Sketch Route. The byte lanes will quickly and easily be routed. Often design teams need to add notes or information to designs that often require more than just a few words. One way to accomplish this is to add hyperlinks to the layout. Hyperlinks can point to documents with large amounts of information that are important to the design. In this example, we will add an app note in the form of a manufacturer's PDF for DDR4 component U802. Once the hyperlink has been added, the document can easily be opened by anyone working on the design by using right-click Open Hyperlink option as seen here. Hyperlinks can be edited and removed at any time. For designs that require backdrill, there's often a need to include this backdrill information that is required for multi-laminate fabrication processes. Using the backdrill function, we can easily select the layer span ranges along with the must not cut layers. This information is then added to the backdrill table. The internal laminate backdrill CSV files are then automatically created. For teams working with high-speed designs, there are times when new routing techniques are required. One of those is complex via structures. These are via models that are user-defined and used for high-speed routing, layer transitions, and stitching vias. Many times, these complex via structures are defined by analysis using 3D solver tools like hyperlinks. In this example, we see a diff pair being routed using normal diff pair via solution. It has been determined that a high-speed via structure using shielding vias and trace obstruct is required. Like before, we will route the diff pair in the same manner, but instead we will choose a pre-created complex via structure. Once chosen, it will be attached to the cursor for placement. Notice the error that is being reported based on the trace obstruct included in the via model when we try to place at certain rotations. After place, the designer simply continues routing the diff pair as normal. Lastly, the complex via model can be selected and moved in the same way the standard via structure can be. With aggressive project development cycles or customers demanding shorter development times, take advantage of previous designs via design reuse and powerful interactive routing technology using sketch planning and routing. With Expedition Enterprise, your design team will have all the tools required to develop a high-quality product in less time.